So today we're going to learn about relations, and relations have to do with functions and ordered pairs, and I want to break that down for you a little bit. Okay, so we already know what ordered pairs are, right? We know that ordered pairs are some kind of an X and some kind of a Y value, right? 1, 2 could be a set of ordered pairs, okay? The ordered pairs in terms of functions are driven by whatever the function tells us to do, all right? Like we did, the first thing we did was f of x is 3x plus 1, and the domain they gave us, this was in our little warm-up, -2, -1, 0, 1, and 2. In our warm-up, we were given these, and we found out that if we put -2 in for x, we would get, was it a 5 as our f of x? Remember, output, f of x, y value, they're all referring to the same thing. And if I plugged in a -1 as my x value, I would get, what was it, a -2, if I'm doing my arithmetic correctly. And I could keep on going, 0, 1, and 2, and the outputs that I had were 1, 4, and 7, okay? Notice that for every x value, there is only one y value, okay? So -2 is married to the 5. That's it, okay? That, my friend, is a definition of a relation, okay? A relation is a function wherein every x has only one y, okay? The book's definition says a function is a relationship in which different ordered pairs have different first coordinates, okay? I'm just saying it a different way. For me, it's just simpler to remember that x's are not repeated, okay? I can have 10 points, or 10 coordinates, 10 pairs, but at no time does the x repeat itself, all right? Let's look at another example, and so, bear with me. So this function that I just shared with you is a relation, okay? It is a relation. Think of it this way. In a relationship, you expect your boyfriend to stay with you, nobody else, okay? For every x, there's only one y, all right? Now, another one we did, this was example 4 in our warm-ups. X is f of x, it was g of x, wasn't it? The output is the absolute value of x, and they gave us -6, -3, 0, 3, and 6. This was our domain for that one. That was what, number 4? So my x's, I'm going to start with -6. So if x is -6, what is the output of -6? 6. And if you put in x as -3, the output is 3. You put in 0, the output is running out of room. You put in 3, the output is 3. You put in 6, the output is, okay, is this function a relation? Yes, this is a relation. The y's did get repeated, but that's okay. X isn't repeated, okay? X isn't repeated. That's the key here, okay? That's the key to this scenario. Now, let's grab our worksheet, all right? Grab your worksheet. I'm going to switch to my worksheet, okay? So So they give you some of the same definitions that I had in the book. A relation, just remember that, that when they're talking, I'm sorry, I'm saying this backwards. A relation is a function when x is not repeated. A relation is a function when x isn't repeated. Okay? So ordered pairs, coordinates, a relation. Okay? A relation is a function when x is not repeated. Okay? And they give us some examples here. I want you to kind of look at this with me. You can see it on your own. We've got a list. 0, -1, 2, 3, 5, 9. The domain is 0, 2, and 5. It never gets repeated. Therefore, this relation, this set of numbers, indeed is a function. Whereas 1, 2, 3, 4, 3, 5, this relation is not a function. It's not a function because the 3 got repeated there. Okay? All right. The key here, and I like this in caution, a relation is just a list of x's and y's. Okay? Whereas a function can have repeating y's but never ever repeating x's. All right? They give you some symbols and some explanations here, and I want to go down into example 1. Okay, let's look at A, for example. Give the domain and the range of each relation and tell me whether it's a function. Okay, so the domain, remember domain is the input, also known as the x value. All right, so x, for this particular relation, x falls between -2 and 2. Okay, so x falls between -2 and 2. I'm only talking about the input. I'm only talking about the x value.